In this video, I will discuss some NEET PYQs from the topic Mechanical Properties of Fluids. These questions are based on hydrostatic pressure and compressibility of fluids. Hydro means water, and the property of water is it's incompressible in the sense the change in the volume when the pressure is applied to it, it's very small. So this can be approximately zero. Static means water is at rest, that it's not moving. So pressure due to water at rest, it's hydrostatic pressure. So if you have a column of water, it's in a large vessel, there is water here. So pressure at any point inside the water is because of the weight of the fluid or water above it. And pressure is force per unit area. And here the force is because of the weight of the water. So it's mass of the water into G divided by area. So let me take a column which has got a cross section area CE. So to find the pressure at this point, we can find the pressure acting on this area A and divide by the area, it will give the pressure. So this mass is nothing but volume into density into G by A. And the volume of water, it's volume of cylinder, which is the cross section area into height. Volume is volume of cylinder, it's area into the height of the cylinder. This is height h. So if I put that thing here, A will cancel, I'll get rho G h. So pressure at any point inside water, it's the height of water above it. Suppose this is h1. The pressure at this point is rho G h1, where rho is density of this water and G is acceleration due to gravity. So at this point, at the bottommost point, the pressure will be maximum. It's rho G into this height, the full height. So this one basic concept we'll be using. Second one is compressibility. Compressibility is defined as 1 by bulk modulus. And bulk modulus, like Young's modulus, is defined as stress by strain. In the fluid, stress is pressure and strain is measure of deformation, which is the change in the volume by original volume. When the pressure is applied, the volume will decrease. The change in the volume is negative. So you put a negative sign to make this quantity positive. So this is the compressibility of a fluid is defined. And the unit of bulk modulus is pressure. This is dimensionless quantity. So P is in, if it is in Pascal, bulk modulus is also in Pascal. And compressibility by 1 by Pascal units. So with this understanding, you can solve this NEET PYQs. Timestamps are given in the description box. You can watch parts of video if you're running short of time. I'll discuss some 5 questions. This is the first one. A U tube with both ends open to the atmosphere is partially filled with water. Oil, which is immiscible with water, is poured on one side until it stands at a distance of 10 mm above the water level on the other side. Meanwhile, the water rises by 65 mm from its original level. See diagram. The density of oil is. 4 options are given. So initially only water is poured, and then when the oil is poured on one side, it will push water to some height here. So the dimensions are given. So you can pause and run this question. So it's a hydrostatic situation, so everything is at rest. So if you consider this part of this volume of water, that is at rest. So whatever is the force acting on this volume of water on this side and on this side, both should be equal. Only then they are at rest. And the force on this side is pressure at point B into this area, CA. And this force is pressure at point C into this area. So both these forces should be same. Only then this column of water will be in balance. A is same, so A will cancel. So PB and PC should be same. Pressure at point B and pressure at point C should be equal for this part of the water to be at rest. Pressure at point B is because of the weight of the fluid above it. So this is oil. So rho GH of oil. Pressure due to a liquid column is rho GH, which I discussed in the beginning, of the oil. Height of the oil, density of the oil. So this much height of oil into the density of oil into G. Pressure at point C. Above point C, water is there. Rho GH of water. G will cancel. Height of water is from here to here, 130 mm. And height of oil is from here to here, which is 130 plus 10, 140 mm. Mm will cancel. There is no need to convert the units. And density of water is 1000 kg per meter cube. It will be given somewhere in the question paper 2017. So this will give me the density of oil, rho naught, as 1000 into 13 by 14. So oil is lighter compared to water by a factor 13 by 14. This is less than 1. So since the oil is light, more amount of oil is balancing smaller amount of water. Oil is less dense. So this manipulation we have to do. 1 by 13 by 14 can be written as 1 by 1. 1 minus 1 by 14. So this is nothing but 1000 minus 1000 by 14. 1000 by 14 is cancelling to 500. So 7 sevens are 49, 10, 7 ones are 7, and then remainder is 3. So 3 by 7. So 1000 minus this thing. 1000 minus 71 is 930, 929 minus 3 by 7. So little bit less than 929. So to find a easy way of solving this thing, so this thing you can write as 1 minus 1 by 14. So it's 1000 minus 1000 by 14, 500 by 7. So to find this thing, a simple way to do it, so that you get the answer without any mistakes. C is the correct option. This is what I explained here. Pressure at point B and C are same because this column of water is at rest. So that means force on this side and force on this side on this amount of water should be same. So pressure at point B should be same as pressure at point C. Pressure at point B is rho GH of the liquid above it, which is oil, and pressure at point C is rho GH of the liquid above it, which is water. So simplifying, you will get this answer. This is the next question. You can read it. Two non-mixing liquids, densities rho and n rho, n greater than 1, are put in a container. The height of each liquid is h. A solid cylinder of length L and density D is put in this container. The cylinder floats with its axis vertical and length PL, P less than 1, in denser liquid. The density D is equal to. In pause and attempt this question. So two liquids, heavier liquid will be at the bottom. Heavier liquid density is n rho because n is greater than 1, and the lighter liquid is rho, which will be at the top. Heavy liquid will sink to the bottom. So cylinder axis is vertical and some part of the cylinder is inside this heavier liquid, and that length is P into L, and the total length is of the cylinder is L. So P is less than 1. So you have to find this density of this cylinder D. Cylinder has got some density D. So since the thing is at, okay, this liquid is at rest, so pressure at this point and pressure at this point will be same. In a liquid, pressure at any point which is the same level will be same. If the pressure is different, then the liquid will move and there will be mixing. Since the static condition, there is no mixing of liquid, so pressure at any point on the horizontal line is same. So let me call this point A and this is point B. So pressure at point A and B are same. Pressure at point B is because of the liquid above it, the weight of the liquid above it. And pressure at point A is because of the weight of the cylinder. Because above A there is only the cylinder. A is a point just below the cylinder, almost touching the cylinder, and point B is the same level. Pressure at point B is rho GH of the liquid above it. So rho, density of this n rho, G into H of this liquid, that is PL, plus some weight of this much of liquid, rho GH of that liquid, so rho G, and height of this one is 4 length is L and PL has gone here, so it's L minus PL. Pressure at point E is because the weight of the cylinder, so mass of the cylinder into G. Mass of the cylinder is volume of the cylinder, sorry, and also divided by area. Pressure is the weight of this thing divided by area. Pressure is force per unit area. And mass is volume into density of the cylinder. Volume into density of the cylinder into G divided by A. And volume is A into H of a cylinder. So A will cancel and H will remain. So HDG will be equal to this right side. So this plus this is the entire right side. So rho G L will come out. Rho G L NP rho G L, if it comes out, will be 1 minus P. G can be cancelled. So density D, and H is nothing but L. Height of the cylinder. So L will cancel. So density is rho into NP plus 1 minus P. So here P terms has been taken out separately. So this can be written as 1 plus N minus 1 into P. 1 plus N minus 1 into P. Option D is the correct answer. This is what I explained here. Cylinder, density D. This bottom liquid is N rho density. Above liquid is rho. So pressure at point A and B are same because of the same horizontal level. Pressure at point A and B are same. So pressure at point is because of the weight of the cylinder, volume of the cylinder, cross-section area into the length. That is the volume. Density is the mass into G. That is the force divided by the area. That will be the pressure. Area will cancel, and this is rho GH of the liquid. The bottom liquid, rho is N rho G, and then H is PL. The top liquid, rho G, and then height is 1 minus P into L. So simplifying, we'll get the density as this one. To the next question, the approximate depth of an ocean is 2,600 meters. The compressibility of water is 45.4 into 10 to the minus 7 per Pascal. A density of water is 1000 kg per meter cube. What is the fractional compression of water will be obtained at the bottom of the ocean? So ocean, so this is the bottom surface. So the depth is 2700 meter. K of the water is given and density is given. So compressibility K is 1 by bulk modulus, and bulk modulus is stress by strain. Strain by strain will go up. That is delta V by V with a negative sign, because when the pressure is applied, the volume will decrease. So putting a negative sign will make this thing positive. So you have to find fractional compression of water. So you have to find this quantity. So that is nothing but minus delta V by V is K into P. K value is 45.4 10 to minus 11 per Pascal, and the pressure is because of the weight of the water above it. So rho GH of water. So rho of water, which is 1000, and then height of water. That will be to the right hand side. Rho of water is 1000 SI units, and G value is let me take it as 10, and height of water is 2700 meters. That will be delta V by V with the minus sign. So 1000, 10 here, 10 here. So 10 raised to 6 with this thing will give me 10 raised to minus 5 into 45.4 into 27. Okay, so we can do an approximation. So this is approximately 45 will decrease it to 40, and then 27 will increase it to 30. So that will be a better approximation. So that will be 1200. So this is approximately 1200. So it will be 1.2 into 10 raised to minus 2. Option B is the correct answer. So this is what is explained here. Compressibility K is 1 by bulk modulus, and bulk modulus is stress by strain. So from this you get the fractional change in the volume, delta V by V with the minus sign, because for this quantity to be positive, we have to put a minus sign because delta V is negative. When it's getting compressed, delta V is negative quantity. So to make this thing positive, minus sign has to be attached to the delta V. K is given, and pressure is because of the weight of the water about, so rho GH of water. Rho is 1000 for water, G is 10, and height is given 2700 meters. Simplify, will get 1.2 10 raised to minus 2. Next question. In rising from bottom of a lake to the top, the temperature of air bubble remains unchanged, but its diameter gets doubled. If h is the barometric height, expressed in meter of mercury of relative density rho at the surface of lake, the depth of the lake is. You can pause and run this question. So this is the lake surface, and this is the bottom of the lake. Air bubble here, when it comes up, the volume will increase because here the compression is more because the pressure is more. Here the pressure is less, so it will expand. So here if the diameter is d, at the top the diameter is getting doubled. It's given in the question. So you have to find the depth of this lake. So this air inside this one, we can assume it's ideal gas. So for ideal gas, we have this equation P equal to nRT. So from here to here, the amount of gas is same. So N is same, and R is a constant which is same, and temperature is same. Temperature unchanged, temperature is same. So for this one and this one, PV should be same. So we can write P1 V1 equal to P2 V2. So pressure of air here into the volume and pressure of air into the volume here, both should be equal. Let me call this point 1, and this is condition 2. Pressure at point 1 is the pressure here, which is because of this water and the atmospheric pressure. So P1 is atmospheric pressure plus rho GH of this water. Rho GH of water. And this is H of water is the one we have to find out. into V1 is pressure at point 2, which is atmospheric pressure. At this point, the pressure is because of the atmosphere, into volume 2. And volume is proportional to diameter cube, d1 cube. Volume of sphere is 4 by 3 pi r cube, and r is d by 2. R is nothing but d by 2. So volume is proportional to cube of the diameter. So this is also proportional to d2 cube. So other factors will cancel, 4 by 3 pi and then by 2 cube, and d2 is twice d. So this will be 8 times PA, and here you have 1 PA and then rho g h. So density of water in terms of relative density will be 1. Here mercury density is rho relative density. That means density of mercury is rho times more compared to density of water. And density of water in terms of relative density will be 1. So this is 1. So G into height of water, which is the depth here, we have to find out. That's equal to 8 PA minus 1 PA here. This thing will give a factor of 8. After that, this one, if it goes on the left side, will become minus. So depth of the lake, and atmospheric pressure is given in terms of mercury, which is the barometric height. So this is 7 times atmospheric pressure. And atmospheric pressure in terms of mercury is rho g h of mercury, and this height is this one. So 7 times rho g and h. So g and g will cancel. I will give the depth as 7 times rho g h. 7 times rho into h. G will cancel. D is the correct option. This is what I explained here. Ideal gas equation P equal to nRT. This air bubble, we can assume it's ideal. So amount of gas is fixed, so N is same at bottom point and top point. R is a constant, and temperature is same, which is given in the question. So that means P we should match for at the bottom and the top. So P1 V1 equal to P2 V2. P1 at the bottom is atmospheric pressure plus the pressure with the water, and this is rho gh of water, and rho in terms of relative density will be 1, and atmospheric pressure is rho gh, and this rho is mercury density, and this height is mercury height. So this one. So this, there is a factor of 8 here, because on the top the diameter is doubled, so volume has become 8 times. This is the next question. The compressibility of water is 4 × 10⁻⁵ per unit pressure atmosphere. The decrease in volume of 100 centimeter cube of water under pressure of 100 atmosphere will be. Compressibility is given 1 by bulk modulus. Bulk modulus is stress by strain. Strain will go up, so will be delta V by V with the minus sign, because it's getting compressed. So K is given decrease in volume of 1000. So we have to find delta V or minus delta V. Because delta V is negative, so minus delta V is positive. It will become K into P into V. So compressibility is 4 × 10⁻⁵. per atmospheric pressure. And atmospheric pressure is P, but actually this thing is inside the wall, inside water. It's under the pressure of 100 atmosphere. So pressure in terms of atmospheric pressure is 100 times atmospheric pressure. So this per atmospheric pressure, this per atmospheric pressure and atmospheric pressure will cancel. Into volume is 100 centimeter cube. That is minus delta V. This is a dimensionless quantity because this unit is 1 by pressure and this is pressure. So these two will become dimensionless. So whatever is the dimension of this volume is same as the dimension of this delta V. So this is 4 into 10 raised to minus 1. A is the correct option. Compressibility is defined as 1 by bulk modulus. Bulk modulus is stress by strain. So from this you get, so minus delta V is K into P into V. K is given as 4 into 10 to the minus 5 per atmospheric pressure, and this pressure is 10 times atmospheric pressure, and the volume is 100 centimeter cube. So from this get the answer as 0.4.